Okay, so we've been looking at these percents and calculations. It's time to look at word problems. Another reason why I like using the proportion for a percent is it actually helps with word problems. For example, let's just do this. Let's say that PDQ Incorporated estimates their gross profit for a period, or just gross profit, as 14% of net sales. What is their net sales in a period where gross profit is estimated at $296,000. Oops, sorry, not 296, 294, I should say. 294,000. Well, we have a percent given here, the 14%. So we'll start with that. But before I finish this and do the other side, let's just label what the 14 stands for. The 14% represents what? The gross profit is estimated as 14%. So that is the gross profit. Now the 100 always represents the whole amount, or the amount that the piece, the portion, the 14 is based off of. In this case, it's based off of the net sales. So the 100 represents the net sales. Now in a problem like this, in a percent problem, there's always has to be two other numbers. Now one of them might be the number we're looking for. But here we have the 294. Does that represent the gross profit or the net sales? Gross profit is estimated at 294,000. Now before we cross multiply and divide to find that missing number, I want to ask, this missing number represents net sales. Is that what we're looking for here? Yeah, what is their net sales in a period, blah, blah, blah. So that is what we're looking for. So we can cross multiply and divide here and get 2,100,000, correct? So the proportion actually helped us solve the problem by labeling it and keeping track of the pieces. It's just matching up things that represent the same thing. Let's say that Pat's weekly salary is $1,800. Pat pays 32% in taxes. Find Pat's take-home pay. In other words, how much does Pat take home after the taxes are paid? Do we have a percent here? Yes, 32%. So that's 32 over 100. Again, before we fill in the rest of this, let's label the 32. What does the 32 represent? Percent, it's the taxes, right? So 32% is the taxes. That's what Pat pays in taxes. What does the 100 represent? His weekly salary, or total pay, right? Do we have any other numbers that represent either one of those? Weekly salary, his total pay is $1,800. So now we can find the amount he pays in taxes. But before we do that, are we looking for the amount he pays in taxes? No. We're looking for the take-home pay. If we knew the amount that was paid in taxes, could we use it to find what we're looking for? Yes, we can. So we're going to do 32 times 1,800 is 5,000 or 57,600 divided by 100 is 576. Now we just said that's not what we're looking for, but how do we use that to find what we're looking for? Perfect. 1,800 is the pay minus the taxes of 576, which will give us 1,224 is Pat's take-home pay. Let's see, Chris receives a 4% raise for an increase of 68 cents per hour. What is Chris's new pay? New wage. Do you have a percent? 4%. 4 over 100. What's the 4 represent? The raise. What's the 100 represent? The total, or in this case, the starting pay, starting wage. Remember, we said 100 is either the whole thing or the beginning or starting value. So that's the starting pay in this case. So over on the other side, we have the 68 cents. Where does that go? That goes on top. That represents the raise, the amount of the raise. We can cross multiply and divide now to get the starting pay, the starting wage. Is that what we're looking for? No, but we can use it to find the new wage, can't we? Cross multiply and divide, we get 100 times 0.68 divided by 4. 17 bucks. $17 is the old wage. So $17 plus 68 cents. $17.68 is the new wage. Make sense? Both of these last couple of problems have kind of hinted at the next topic, an increase or a decrease. So let's do Tom receives a 12% discount. How much does Tom pay for an item with list price of $650? Well, we have a percent here, the 12%. 12 over 100. The 12 represents the discount. 100 represents the whole thing, or in this case, that'd be the list price. That's the original price before any discounts. The 650 represents what? That also represents the list price. So 650 will go on bottom. We're going to go ahead and cross multiply and divide here. 12 times 650 divided by 100 is $78. That is the amount of the discount. But what we're looking for here is the amount Tom pays. So we're going to have to 650 minus 78, which is going to give us $572. Now I wrote that out very deliberately over here because I want to look at what happened here. When we have a discount, it's a percent decrease problem. We're taking an item and we're decreasing it by a percent to get a new amount. Here we have the, in this case it'll be list price. I'm going to subtract the discount. What we have down here is the amount paid. And in a problem like this, as we've seen, every item is described by a number, but then also by a percent. Yes?
Would it just be easier to multiply the 650 by what you've done before, so that 88%?
That's where we're going with this. Yep, exactly. So each of these items, in this case, is described by a dollar amount, but they'll be described by a percent. And as we look at it, we see the 12%. That's the amount of the discount. And it doesn't look like we have any other information. But in a percent problem, we always have the 100%, which is going to represent the initial amount or the list price. And since the discount is subtracted from that list price, we can do the same with the percents. 100 minus 12 is 88%. So what we find here is the amount that is paid matches up with 88% of that list price. So what we could have done, just as you said, instead of finding 12% and subtracting it, we could have just found 100 minus 12 is 88% of that list price. We cross multiply and divide right here, we're going to get 572. Now in this problem, it's not much more work to do it, finding the 12% and subtract it out. But there will be times where we cannot do that. For example, everybody get that all down, or do you want me to wait a second? So for example, after an 8% discount, Dan pays $230. How much did Dan save? Just to satisfy my curiosity, I want you to try this in your notes quick. So we have 8% here. It's 8 over 100. Let's look at defining what each of those represents. The 8% here obviously represents the discount. What's the 100% represent? The starting price, right? The list price, starting price, however you want to put it. The actual words you use don't matter as long as you understand what it stands for. We are looking for how much did Dan save. That is the amount of the discount, right? So I put in 230 here and cross multiply and divide, right? What's the 230 represent? How much you paid? Is that the starting price? No, that's after the discount. I cannot put 230 in here. So right now I don't have either number here. I cannot use the 8% to solve this problem. Well, I'm going to use it, but not like this. Like you said before, I have to look at this and say, hey, the 8% discount means you paid 92%. 100 minus 8 is 92%. That's the amount paid. The 100 is still the starting price. And 230 represents the amount paid. That goes on top. We can cross multiply 100 times 230. 23,000 divided by 92. It's $250. So the amount, the original amount was $250. Now, once again, let's go back and answer a question. What was the question that was asked here? How much did he save? Have we found that yet? Well, sort of. We can get to it, but we haven't found it yet. How do we find it from what we have? 250 minus 230. The original amount minus the amount paid. Dan had to save $20. Now, I do a lot of messing around here. There's a structure that I use that makes it a little bit easier. And I do it like this. I write out the original price or the list price, again, whatever words you want to use in there, minus a discount, give the amount paid, just like we did before. And again, each of those numbers is described by a percent and a dollar amount. We know the amount paid is the $230, so I'm going to put that in there. We know the discount was 8%, so I'm going to put 8 on the percent side of the discount. Do I know anything else? In the percent problem, I always have what? The 100. That is the original price is 100%. So now that I have this, I can fill in what for the percent paid? Original price minus discount. So 100 minus 8 is 92%. What am I looking for? Am I looking for the original price or the amount of the discount? How much you saved, so that would be the amount of the discount is what I'm looking for, right? I don't need this top line at all. So now I can, rather than having to pull this out into make a proportion, I can cross multiply and divide right here in the table. 8 times 230 divided by 92, $20. Proportions like these that we've been using to solve our percents, all they are is a structure that matches numbers that describe the same thing. This table does the same thing and allows me to put more than just a pair of them in there so that we can match up several things and look at here. We had to take the item that we knew both sides of. For the amount paid, we knew both the percent and the dollar amount, and we used that to find the item that we're looking for. Any of you have $20 as your answer for that? Is the amount saved? A couple of you? Okay. If you tried to find 8% of the 230, you would ended up with something like, oh, what was it? $18.40, something like that. Yeah. So you're off by $1.60. So anyway, after 7%, let's do this. Gotta start with a little bit simpler example. Pete buys $380 of merchandise, but because I'm too lazy to spell merchandise right now, Pete buys $380 of stuff. Sales tax is 7%. How much does Pete pay? Well, 7%, 7 out of 100. 7 represents the tax. 100 represents the original price again, not the amount paid, but the original price. We know 380 is the original price. We can cross multiply and divide here, and we're going to get what? 2660, I believe. Does that look right? Well, that's not what we want, though. We want the amount paid, don't we? How do we get that from this? We add it. Good. We take 380. We're going to add the $26.60 to get $406.60. Now you probably notice I'm sneaking in this thing again. A little table. So again, what we have represented here, this is the original price, or the list price, or however you want to list it, price before tax, or whatever. To that, we are adding the tax, and this is going to give us the amount paid. Once again, we have percents on one side and dollars on the other. We have the 7% for the tax. What other percent do we always have? 100 is the original price. So that means this time we don't do 100 minus 7, we do 100 plus 7 because we add tax. So the amount paid is 107%. So what we could have done here is similar to before. Instead of finding 7% and adding it on, we could have found 107% of the 380. And when we cross multiply and divide, that would have given us the $406.60. What do you think? Better than a sharp stick in you? What's that?
Wouldn't it just be quicker to multiply the 380 by 1.07%?
Yes, if you wanted to use the rate, you could do 1.07 is 107%. Yep. Yeah, it is. The reason I go through all this, though, is, of course, I'm going to make it worse. If you haven't learned that yet, I always make it worse. In a problem like this, again, it's about the same amount of effort to go either way. You could find the 7% and add it on, or you could fairly simply use the rate if you wanted to. Yeah. Or we end up with a problem like this. After a 24% increase, a ticket now costs $496. How much did it increase? Any notes? I want you to try that for me again. How'd you go about this one? Backwards the last one, okay. Okay. So what'd you do?
Multiplying by 1.24 and divided by 1.24.
To do this one, I like to set it up this way. So we have an old price, and we're going to add an increase to it, kind of like adding taxes, and we're going to get a new price. We have percents and we have dollars. And again, I'm just making this table to help me organize my thoughts. So you can see how I'm organizing my thoughts. You don't actually have to draw the table out. So on the percent side, we have 24%, which represents what? The increase. 100% goes on the old price. On the let's just finish off the percent side. What's going to go in for the new price? 124. We add it together. Right? It's an adding now instead of subtract. On the dollar side, we have the 496, which goes where? The new price. That's now. What are we looking for? The increase. How much did the price go up? So we don't care what the old price was. Now, when you divide it by 1.24, that's going to give you the old price. You have to go back and do something to find the increase, right? So now to find the increase, we can cross multiply and divide right in the table. 24 times 496 divided by 124 is, oops, that's not 400. 96, right? How many of you got $96 increase? A couple of you? Okay. So the moral of the story is these percent increase problems can be fairly tricky. So be careful with them. Anybody have any questions right now? Okay. What I want to do is I want to switch gears a little bit and go into reviewing for our test that's next week. Certain topics I'm just going to list for you. Other topics I will do examples for you. How many questions is it going to be? Well, depending on how much I change it from last year or last semester, somewhere around anywhere from 35 to 50. I have like 4 different versions of it I modify every year. The 50 question one's the easier one, just so you know. So anyway, we started out talking about fractions and decimals. So fair game would be operations with fractions and decimals, converting between fractions and decimals, along with that, building upon that, we had order of operations. I'll do a couple of examples of these. So you might have something like something like this. What would we do? What do we do first? The parentheses. Inside the parentheses, what's first? That's 2.7, yes. Yep. The only multiply is the little x there. So inside here I have to do the 2.7 times 3 first, which is going to be 8.1. What's next? 4.1 minus 8.1 is -4. And then multiply 0.5 times negative 4 is negative 2. And then 0.3 plus negative 2 is going to be negative 1.7. Any questions? How about something like this? Tell me where to start. You gotta do everything on top first. So I'm going to rewrite that. What do I have to do up there? 3 times 7 is 21. And then addition and subtraction, left to right. 8 plus 21 is 29. Minus 1, 28. The top is 28. What's next? We go to the bottom. Multiplying first. 6 times 4 is 24. And then 5 times 2 is 10. And then 24 minus 10? 14. Now what? 24 divided by 14? It's 2. Anybody really scared of order of operations problems? Okay. Make sure you're tired for the test. Make sure you're tired for the test.
Yeah, I think I should do
Last week we worked on solving equations. 7x plus 11 equals 46. Now you remember what we had to do with these is we looked at how it was put together, how it was built, and we had to take it apart. So to solve this, we're taking it apart. What do we have to do first? We have to subtract 11. That would have been the last piece put on this when it was built. It has to be the first piece we take off. So 7x equals 35. And then divide by 7. X equals 5. Now, as you've learned, I don't leave things like that. So we might have something like this. What would I do with that? Perfect. The variable appears twice, but it's once on each side, so I have to get rid of 1. The smaller one's negative 6, so I'm going to get rid of it by adding 6x. Adding 6x here gives me 11x plus 13 equals 57. And then, yeah. Well, it's a negative 6x, right? To completely get rid of something, I either have to subtract it, or if it's negative, I have to add it. Okay, that'll get to 0. You can't totally wipe something out by multiplying or dividing by it. Multiplication or division is when you need to leave a piece of it behind. See, like right here, I want to completely get rid of the 13, so I either have to add or subtract it. It's positive, so I'm going to subtract it. So it's gone there. Notice there's no trace of it left behind. It's totally gone. That's why I subtracted it. And that's right here. I wanted to totally get rid of that negative 6x, so I had to add it to completely get rid of it. Now the 11x here, I need to leave the x behind. I don't want to get rid of the x. I have to keep that. So to get rid of the 11, I have to either multiply or divide. Nope. You get the same answer. So I'm going to divide by 11 to get rid of it. The reason I'm dividing is that division or multiplication leaves a piece behind. I have to leave that x behind. 44 divided by 11 is 4. So x equals 4. If you had subtracted the 5 first, you'd end up with negative 44 equals negative 11x, and you divided the negatives and divide out, so it becomes positive 4. Tell me what to do here. Perfect. Yeah, we see parentheses. It should always draw our attention there first. There's nothing to do inside these parentheses. So we're going to have to multiply or distribute to 7. 7 times 3x is 21x. What's next? 7 times negative 5? Negative 35. And then add 35. 21x equals 63. And then divide by 21. X equals 3. What do you think so far? Doing well? How would I solve this one? Well, what's been done to x? How is this built? X has the 3/8 there. What operation attaches the 3/8 to the x? It's multiplied. So to get rid of it, we have to divide by 3/8. That'd make that be gone. We have to divide by 3/8 over here. It's not just a matter of dividing our fractions, right? 4 and 5/6 divided by 3/8. I have to turn the 4 and 5/6 into an improper fraction. How do I do that? Perfect. 4 times 6 is 24, plus 5 is 29, 6. And then I'm going to, instead of dividing by 3/8, I'm going to multiply by 8/3. Cross-canceling the 6 and the 8 because they both divide by 2. Gives me 4 and 3. 29 times 4 is 116. 3 times 3 is 9. Which reduces to 12 and 8/9. Questions?
Just go back down to 137.
That one? Let's step it up a little bit. Tell me what to do here. Okay, I see the parentheses, and again, I should check to make sure there's nothing I can do inside of them. So I go left to right. This one, there's nothing to do inside, so but it can be multiplied by the 5, so I'll distribute the 5. 5 times 2x, 10x, and then 5 times 8 is positive 40. What's next? Next parentheses, nothing to do inside, but I'm going to have to multiply them by, not 3, Closer. Oh, I thought you just said 3 times. I didn't hear the negative. Sorry. Negative 3 times 3x is negative 9x. And then negative 3 times negative 5 is a positive 15. Now there's still stuff I can combine over here. What more can I combine? 10x and negative 9x makes 1x, or just x I could put. Anything else? 40 and 15 make a positive 55. 4x minus 2. Now what? Careful. I have an x on each side. I want to get the x's. I want to get down to 1x before I do anything else. Subtract 1x. So 55. I don't have to write 1. I just subtract x. Could work. So 55 equals 3x minus 2. And then, now I can add 2. 57 equals 3x. And then, divide by 3. 19 equals x. How we doing? It could still work out in most cases, but sometimes it's always safest to get it down to a single x before you start moving anything side to side. Yes.
That for all of these equations and stuff, that I'm trying to find, I can't find it in my notes. The order of operations is parentheses first, and then what was the rest of it?
Ah, okay. Order of operations. First is enclosing symbols, which is your parentheses and your fraction bar, and if you have square roots. Second is exponents, which is your powers and roots. Third is multiplication and division. Then fourth is addition and subtraction. Please excuse my dear Aunt Sally. Use P parentheses for P up there. Yeah, please excuse my dear Aunt Sally. PEMDAS, yeah. Okay, now tonight we covered percents. Make sure that you are comfortable converting a fraction to a percent to a fraction, percent to a decimal, and a decimal to a fraction. And then, of course, all of the percent calculations we did tonight, the simple ones like find 18% of 70 on up to the story problems and the percent increase and decrease ones that we did. One that we didn't really do much of is, let's look at something like this. Let's say your wage goes $14 per hour to $15.26 an hour. What is the percent increase? Well, we're looking for a percent here. What's our percent going to represent? The increase. We're looking for the percent increase. What does the 100 represent? 100 is always the total amount or the beginning value, starting value. So on the other side over here, do we have the starting amount? Yes, $14 per hour. Do we have the increase? Sort of. We don't have it given, but we can find it. What do we have to do to get the increase, the dollar amount of the increase? Yeah, 15.26 minus 14 is $1.26. Now we can find our percent increase. So notice it wasn't the 15.26 that went here, it was the difference, the increase that goes there. So 100 times 126 divided by 14. 9%. Any questions? So let's say that 18% of students fail math class. I'm not trying to scare anybody, I swear. In a class of 75 going to work? Yeah, 75 won't work. In a class of 150 students, how many will fail? What do I do? 18% is 18 over 100. 18 represents fail, right? Ones that failed. 100 represents total students. Yep. On the other side, I have the 150. Does that represent the amount that fail? No. The total amount? Yes. Am I looking for the amount that fail? Yes. 18 times 150 divided by 100 is 27. So 27 that fail out of 150. Other word problems. Does anybody need a break? I know I'm... Is it okay if I just push right through and get done a little early? Okay. So, other word problems. Do you need a break? Sure? Okay. Other types of word problems we looked at. Let's say we have something like... let's see here. Let's do shift A against shift B. So shift A produces 3 times as much as shift B. Total production is 1,000 items. how much did each shift produce? This one's kind of review from last week, so I'm going to let you guys try this one in your notes for just a couple minutes. So we've got shift A and shift B, and we have the number produced. Here's a case where one is referenced off the other. So which one is going to be X? Number produced by shift B. Shift A will be 3X. Now we have a total. Is that total representing the number produced? Yes, it is. So I don't need to do anything else with this. So I add together 3X from shift A plus the X from shift B to give me the total of 1,000. What do I do from there? Add 3X plus X is 4X. 4X equals 1,000. Then what? Divide by 4. X equals 250. Then what? Okay, 250 represents shift B. I need to take 1,000 minus 250, or I can do 3 times 250 to get that shift A is 750. Not so bad. Then, of course, we have word problems like the ones we did at the beginning of class today. Those two. Anybody need to see another one like one of those? We're good? Okay. Trying to see what else we got on here. One that we haven't discussed a whole lot about is proportional problems. We solve proportions when we're dealing with our percents. But a proportional problem is basically dealing with, if we know something stays constant over time, we can compare different rates. For example, let's say that Tim produces 327 items in 3 hours. Now, assuming these stays constant, how much will Tim produce in 8 hours? We could divide this out, 327 divided by 3, to get how much in a single hour, and then multiply it out. But we don't have to do that. These proportions we've been talking about will solve this for us. We have 327 items in 3 hours. Do we have any other numbers that represent the items? No, that's what we're looking for, is how many items, right? Do you have any other numbers that represent the hours? The 8. So now how do we find our missing number? Cross multiply and divide, which is going to give us 172. You got it. How are we feeling? Well, it's a little bit early, but that is all the material we have, and that is everything that, if you can handle all that, you should be ready for the test. There is a new quiz due tonight. Or due tomorrow, sorry. Due tonight, yeah. New quiz is due tomorrow, Friday, at 11:59 p.m. And there is a new homework that is due next week, next Thursday, at, I believe that's due at 6 p.m. The full hour is dedicated for the test next week. Most people are out at about hour and 45 to 2 hours, just so you know. But I give the full 3 hours in case you need a little extra. If you want to come in earlier in the day, I should be in this classroom from like noon or 12:30 on. I can, if there isn't a class in the next room, I can set you over there. There will be a class in here, so you can't work in here, but I should be able to put you in the next classroom and you can work in there if you want to work earlier in the day. With that, the computer lab over here is open. If you want to work on your quizzes and your homework, I'll be here to help you out. Otherwise, we'll see you next week.